Hello students, welcome to Pi Academy, the place for mathematics and science. Dear students, in today's class we are going to continue the chapter triangles, and do remember this is 8th period of this chapter. In the 7th period we were solving the problems in exercise number 6.4. In that total 6 were completed, right? And you also know that this exercise completely related to the concept called areas of similar triangles, is it not? Now, I have written 7th one. Please go through this. This is, prove that the area of an equilateral triangle described on one side of a square is equal to half the area of the equilateral triangle described on one of its diagonals. Hope that you have understood. It is very simple and is also very important in the examination point of view. Even it can be given either for 1 mark or for 2 marks. Just by going through the whole statement, you can come to know that they are given two geometrical figures. Can you tell what are these? Yes, one is equilateral triangle and another one is square. Let's go for drawing the appropriate geometrical figure to understand the whole statement much better way. Look here. First, I'll draw a square. And you all know that square is a quadrilateral in which all sides are equal and each angle is 90 degree. Right? Here, let us name this square as ABCD, in which all sides are equal. I am showing with the markings and each angle is 90 degree. Next, equilateral triangle. What is an equilateral triangle? A triangle in which all sides are equal. See, here they have given equilateral triangle described on one side of a square. You may take any one side. I'll take BC. On BC, let us draw an equilateral triangle, and you may call this equilateral triangle as BCE. Then even these sides will also be equal, BC, CE and EB. Next, that's equal to half of the area of another equilateral triangle described on one of its diagonals. This is a square. Dear students, could you tell how many diagonals can be drawn? Yes, two diagonals can be drawn. What are those? One is AC and another one is BD. Let me take the diagonal AC. Right. On AC, let's go for drawing an equilateral triangle. Hope that you all have understood this. And you may call this triangle as ACF. And here, all sides are equal. That is, AC equal to CF is equal to FA. Then what we have to prove? We have to prove that the area of equilateral triangle described on one side of a square, that is area of BCE, is equal to half the area of another equilateral triangle, that is ACF. Followed? Yes. Now, pausing the video, please go for copying from there to here. After that, you may start continue to write with me. Okay, dear students, write the data with me. Data. What is that? One is ABCD is a square. Next, other than that, BCE as well as ACF. ACF are two equilateral triangles. Right? Equilateral triangles. This much has been given. With this information, we are going to prove that area of BCE, triangle BCE, is equal to half the area of triangle ACF. Area of triangle ACF. Dear students, could you tell what type of triangles are these two? They are equilateral triangles. Right? As this problem is related to areas of similar triangles, let's go for using the concept only. We can go for proving this statement in different ways. But I am going to prove this related to the given concept. You all know that all equilateral triangles are similar, right? Please don't go for writing the proof and just look at the book. All equilateral triangles are similar, hence the ratio of their areas will be equal to the square of the ratio of their corresponding sides. Is it not? Look here we can write triangle BCE is similar to triangle ACF because they are equilateral triangles. Then we can write area of BCE by area of ACF is equal to, how do you write? BC by AC whole square is equal to CE by CF whole square equal to B by AF whole square, right? I'll go for taking just only one pair of corresponding sides. And observe BC by AC. Do you know the measurements of these two? BC. How much? We do not know. And AC. AC is also unknown. Then let us go for assuming them. Here, look here. If you take BC as A, what about AC? AC will be root 2 into A. Is it not? Because you all know that in your previous classes you have learned that the diagonal of a square is root 2 into side. Followed? So just go for substituting here. Where BC is assumed as A, then AC, it is root 2 into A. Root 2 into A. Then whole square. This is equal to A square. And root 2 whole square is 2 into A square. A square get cancelled. It is 1 by 2. Now, look here. Area of BCE by area of ACF is equal to 1 by 2. This can be rewritten as area of BCE, it is equal to half into area, I am cross multiplying, area of ACF. See that the statement is proved. Got it? Now I am going to write all the required steps correctly in the proof, and you should also try to write yourself by pausing the video. Just check that what you have written. See, here we have assumed BC as A unit. Then we all know that the diagonal of a square is root 2 into side. So root 2 into side is either AB, BC, CD or DA. All are A only. Hence root 2 into A. Got it? Next. All equilateral triangles are similar. Hence these two triangles BCE and ACF are similar. By using areas of similar triangles, the ratio of their areas will be equal to the square of the ratio of their corresponding sides. And just with substitution, we have proved this statement. Followed? Please go for copying up to here. Let's go through this 8th one. It's very simple. ABC and BDE are two equilateral triangles such that D is the midpoint of BC. Ratio of the areas of triangle ABC and BDE, what it will be? See, very simple. Here I am going to draw an equilateral triangle ABC. ABC, in which all sides are equal. And D is the midpoint of BC. Look here. This is the point D. Hence these two are equal. BDE, that is also an equilateral triangle. BDE is an equilateral triangle. Now, with this information, we have to find out the ratio of areas of triangle ABC by area of triangle BDE. That's equal to, see, we know that all equilateral triangles are similar. Then the ratio of their areas will be equal to the square of the ratio of their corresponding sides. Then we can write, okay, BC by BD whole square. Did you understand? Okay. This is equal to BC. Look, as D is the midpoint of BC, BD equal to CD, and this is half of BC, or else BC is 2 times of BD. Here I'll write 2 times of BD, then by BD, whole square. Then BD and BD get cancelled. 2 square is 4. 4 can be written as 4 by 1. Now what is the ratio? It is 4:1. Hence the answer is option C, 4:1. This is just a rough calculation I have shown. As it is MCQ question, we will go for using the working column to write only this much. Then immediately we will choose the right option. Go through 9th one. This is also very simple. Sides of 2 similar triangles are in the ratio 4:9. Sides, they are given the sides in the ratio 4:9. Then the areas of these triangles are in the ratio. How much? Very simple. We know that theorem on areas of 2 similar triangles. It is the ratio of the areas of 2 similar triangles is equal to the square of the ratio of their corresponding sides. Look here, they are given sides. Then sides whole square, 4 by 9 whole square. 4 square is 16, 9 square is 81. So 16:81. Option D is correct. Did you understand? Okay, look here just rough calculation I am showing. Area of first triangle, triangle 1, and area of triangle 2. It's equal to the side square, side of triangle 1 by side of triangle 2 whole square. What is the side of first triangle? It is 4. Second triangle 9 whole square. This is 16 by 9 square is 81. 16:81. Answer is option D. Followed? Okay. With this, the exercise 6.4 has been completed. Now we are moving to another very important theorem in this chapter. This theorem is also very familiar to us and is related to a right angled triangle. Now let's go for discussing. First, go for copying from there to here. Dear students, here I have drawn a triangle in which one angle is 90 degree. Could you tell what type of triangle it is? Very good. It is a right triangle or right angle triangle. You all know that this is the only one type of triangle in which all sides can be named. Is it not? Observe here. The triangle ABC in which AC, this is the side opposite to right angle. What do you call this side? Very good. It is hypotenuse. Then BC is the side on which the right triangle is standing. This is called base. And observe AB, it is also another side of the triangle and is perpendicular to the base. This is called altitude. Altitude. Dear students, in your previous classes, you have learned one of the important property related to right triangle. Could you tell what it is? Very good. It is Pythagoras property. Then what is the statement of that? It is the square of the hypotenuse, that is AC square, is equal to the sum of the squares of other two sides. What are other two sides? AB square and another side BC and its square, BC square. This is the Pythagoras property. And in today's class, we are going to learn the Pythagoras theorem. We are going to prove this statement. What is the other name of Pythagoras theorem? It is called Baudhayana's theorem. Please go for writing. This is side heading Pythagoras theorem. Write with me. Pythagoras theorem, and in bracket you may also write another name of this theorem. It is Pythagoras theorem. Pythagoras theorem. Write the statement. What is that statement? Yes, in a right triangle, go on writing with me. The square on hypotenuse is equal to the sum of squares of other two sides. Then after that you may go for drawing the right triangle and write the statement. Dear students, to prove this Pythagoras theorem, we have some important results of similarity of triangles related to right triangle. Let me teach you them first. And before going to that, please go for copying up to here. Dear students, now I am going to tell the results of similar triangles related to right triangle. Just observe it. Here I have drawn a triangle ABC in which angle B is 90 degree. And from the vertex of right angle of right triangle, I am going to draw the perpendicular. See, from B we are drawn perpendicular to AC. I call this point as D. Okay. Here, how many triangles are formed on either sides of this perpendicular? Very good. Two triangles. One is BDC and another one is BDA. And these two triangles are similar to the main triangle ABC. And also, they are similar to one another. Did you understand? Like this. Look here. I'll write the results one by one. The first one is, see, in triangle ABC, angle B is 90 degree and BD is perpendicular to AC. If this condition is there, then the triangles that are formed on either sides of the perpendicular are similar to the whole triangle. That is, see that CDB, it should be moved in the same order. First result, triangle CDB is similar to CBA. Followed, triangle CBA. Next, second one is triangle BDA. Triangle BDA similar to triangle again CBA. Triangle CBA. And third one is, and these two triangles are also similar to one another. Triangle CDB. CDB is similar to triangle BDA. Triangle BDA. To remember this, I can just give you one simple diagram. Look here. Here, the vertex of the main triangle CBA like this. This is C, this is B, and this is A. And the other two triangles are CDB. Okay, CDB. Next, one more. BDA. Please do follow the same order. BDA. Observe. CBA is similar to CDB. Next, CBA is similar to BDA. Even I have shown the direction. Then CDB is similar to BDA. Forward, you can just remember this figure. Got it? Now I am going to write the statement, and this statement has been given as a theorem. That is theorem 6.1. No proof. Theorem 6.7. I'll tell you the statement. statement is in a right triangle, then the perpendicular drawn from vertex of right angle of right triangle to the hypotenuse divides it into two triangles, and each of these triangles similar to the whole triangle and also similar to one another. Got it? Yes. Write this heading and try to write the statement yourself. Dear students, I have written the statement. Please go through this. See, if a perpendicular is drawn from the vertex of right angle of right triangle, then the two triangles formed on either sides of the perpendicular are similar to the whole triangle, that is the given triangle, and also these triangles are similar to one another. So after copying this statement, draw this right triangle and write these three important results. Copy this. Dear students, this is one of the important theorem to be asked in the examination. Observe theorem 6.8, that is Pythagoras theorem, which is also called Pythagoras theorem. But how do you expect the question? Can be asked like this: state and prove Pythagoras theorem. Next, another way, directly they may give the statement like this: prove that in a right triangle, the square of the hypotenuse is equal to the sum of the squares of other two sides. Dear students, please don't go for writing anything till I complete this theorem. Just observe the board and concentrate more on my explanation. Here, the statement is, in a right triangle, the square of the hypotenuse is equal to the sum of squares of other two sides. The first step is drawing the appropriate geometrical figure. So, which geometrical figure should be drawn? It is a right triangle. Now, to prove this statement, as I said, we are going to use the results of similar triangles. So that is why I am going to draw the right triangle in horizontal way, like this. Just keep observing and don't draw. See, this is a side and is another side, and from here perpendicular. I've drawn the perpendicular. Yes. You may name this triangle as ABC, in which angle B is 90 degree. See, this is 90 degree. Now, let us write the data. How do you write? It is in triangle ABC. In triangle ABC, what has been given? Angle B is 90 degree. Only this much. With this information, what we are going to prove? See, that is, the square of the hypotenuse is equal to sum of squares of other two sides. Which is the hypotenuse? The side which is opposite to right angle, that is AC. AC square is equal to the sum of squares of other two sides. Other two sides are AB and BC. AB square plus BC square. This is the statement to be proved. And to prove this statement, we need construction. So now I am going to show that construction. That construction is, we have to draw the perpendicular from B to the hypotenuse AC. I call this as BD. Followed, BD is perpendicular to AC. Why this construction is necessary? Again, I am reminding you, to prove this theorem, we will use the results of similar triangles related to right triangle. There also the perpendicular is there. Here I write the construction. Construction is draw BD perpendicular to AC. Then from this construction, how can we go for proving? Look here. Dear students, I have already told you, when you draw the perpendicular from vertex of right angle to the hypotenuse, it divides it into two triangles, and each of these triangles is similar to the whole triangle. That can be shown like this. Okay, this is A, this is B, and this is C. Observe the direction. Next, here is D, A, D, B, then B, D, C. So I go for taking first ABC triangle and ADB triangle. ABC, ADB. In triangle ABC and triangle ADB, in these two triangles, okay, A is common, right? A is an angle of ABC, is also an angle of ADB. Angle A equal to angle A. This is common angle. Next, look here, angle B is 90 degree. What about ADB? That is also 90 degree. This is perpendicular. Here I'll write angle B is an angle of ABC, which is 90 degree, and angle ADB, that is also 90 degree. Here I'll write each is 90 degree. Okay, here in two triangles, two pairs of angles are equal. Which similarity criterion can be used? Very good. That is A similarity by AA similarity. We can write triangle ABC similar to triangle ADB. This part is very important. We know that when two triangles are similar, their corresponding sides will be in the same ratio. Therefore, we can write it as AB by AD is equal to BC by DB is equal to AC by AB. What is the reason? Corresponding sides of similar triangles. Got it? Look here. I am going to take two ratios in which one particular side is common. Look here. Observe the first and last. You can come to know that AB is there, here also, here also. Then go for cross multiplying. It is AB into AB square, which is equal to, now this is AC into AD. Followed? You may call this as statement 1. Now, hope that you have understood up to here. Next, the same way, again I go for taking the whole triangle ABC and triangle BDC. Here I will write, in triangle ABC and triangle, what is that? BDC. Triangle BDC. In this, observe it, angle C is common. Okay. C is an angle of ABC. C is an angle of another triangle BDC. So angle C equal to angle C, which is common angle. Next, 90 degree. Okay, angle B is 90 degree. BDC is also 90 degree. You may write this as it is. Angle B equal to angle BDC. The reason is each angle is 90 degree. Here also you can come to know that two pairs of angles are, corresponding angles are equal. Then which similarity criterion can be used? Very good. Again, by AA similarity. AA similarity, we can write triangle ABC similar to triangle BDC. Now I am going to highlight this. Observe. When these two triangles are similar, then the corresponding sides will be in the same ratio. Hence, we can write AB by BD, which is equal to BC by DC is equal to AC by BC. Here also you have to choose two ratios in which one common side. Which is that? Which are those? They are the last two. Look here. Here is BC. Here is also BC. Go for cross multiplying. BC into BC, this is BC square is equal to, now cross multiply, AC into DC. You may call this as statement 2. Observe, statement 1 is AB square equal to AC into AD. Statement 2 is BC square equal to AC into DC. But the statement what we are going to prove is AC square equal to AB square plus BC square. Okay, AB square plus BC square. Now could you tell what is the next step? It is very good. We are going to add statements 1 and 2. Here I will write adding statements 1 and the statement 2. LHS part. AB square, here LHS part, BC square is equal to RHS part. It is AC into AD plus AC into DC. This is equal to, look here, in the RHS side, you can come to know that AC is common, right? So when you take AC as common, you will get AD plus DC. This is equal to AC into, what is AD plus DC? Observe the figure, AD plus BC, these two together make AC, right? So here I will write AC. What is AC into AC? AC square. Now finally we can write the conclusion that AC square is equal to AB square plus BC square. I'll write that here. AC square equal to AB square plus BC square. Now hence the theorem is proved, or hence the Pythagoras theorem is proved. Hence it is proved. Followed, dear students, repeatedly I have been telling this theorem is very important in the examination point of view. They may ask you both the statement and the proof, or they may ask you to prove just by giving the statement. You will draw the right triangle horizontally, then you will write the data and to be the data and to prove. Next you will go for construction. Construction is BD perpendicular to AC. Then after that, you will go for proving the triangle ABC similar to ADB. You will get the first statement. Next, you will take the triangle ABC and BDC and you will go for writing the second statement. Second statement is here and the first statement is here. And after that, you will add them. On adding, you will get the final result, that is AC square equal to AB square plus BC square. Followed. And now you are going to copy from there to here. Afterwards, we are moving to solve some of the problems of Pythagoras theorem. Copy this. Dear students, now we are moving to worked examples. Actually, one more theorem is there, that is converse of Pythagoras theorem. We will go for proving that in the next class. And now, first we will solve some of the worked examples on Pythagoras theorem only. Look here, this is first one. A ladder is placed against a wall such that its foot is at a distance of 2.5 meters from the wall and its top reaches a window 6 meters above the ground. Find the length of the ladder. Is it not simple? Definitely. Look here, just to make you to understand, I am going to draw the figure. Observe it. See, this is the wall. Observe. This is the wall. It is. Next, a ladder is placed against a wall. Okay. Let me draw the ladder. This is the ladder. Followed. Against the wall. That such that its foot is at a distance of 2.5 meter from the wall. See, this is the foot of the ladder and this is 2.5 meter from the wall, from here. So I can let me call this as A, this as B and it as C. Next, and its top reaches the window 6 meter above the ground. Look here. Here is a window. This is the window. And the top of the ladder reaches the window 6 meter above the ground. Then find the length of the ladder. So we know that the wall is perpendicular to the ground. This is 90 degrees. You are going to find out the length of the ladder, that is AC. Is it not simple? Yes. How? We can go for using Pythagoras theorem. We got the triangle ABC. In triangle ABC, don't go for copying anything, just observe. In triangle ABC, angle B is 90 degree. As it is 90 degree, we can go for using Pythagoras theorem. By Pythagoras theorem, how do you write? It is AC square is equal to AB square plus BC square. As you are going to find out the length of ladder, that is AC, write this as it is, substitute AB and BC. AB is, it is 6 meter, 6 whole square, plus BC 2.5 meter, 2.5 whole square. What is 6 whole square? 6 square is 36, because 6 are 36. 2.5 whole square, you may just multiply 25 and 25. 25 is 625. See, 2.5 into 2.5. After decimal, here one digit. So before two digits, you may put decimal. 6.25. Now add these two. 36 plus 6.5. This is 42.25. Followed. So AC square equal to 42.25. Then AC equal to square root of 42.25. And see that here the number ends with 25. That is, whether it may be decimal or else any number. If it ends with, actually after the decimal we have to read individual digit. 25, that is 42.25, not 42.25. Here I consider this 25 as 25. 25 is a perfect square. It is the square of which number? It is 5. Alright, 5. Point. 42 is there. 42 is the product of two consecutive numbers. Can you tell? It is. Very good. 6 and 7. That is 6 sevens of 42. In that, smaller one is 6. Hence, it will be 6.5. Did you understand? This is the method that we use to find out the square root of any number which ends with 25. So AC equal to 25. AC is nothing but the ladder. Then therefore the length of ladder is 6.5 meter. Dear students, here I have drawn the figure just for the explanation purpose. You may just write, you may draw the triangle ABC only. Then here I'll write data. Look here. What we have to write? First. Then it is the distance of the foot of the ladder from the wall. Distance between foot of ladder and wall. This is BC is equal to 2.5 meter. Then height at which ladder is placed. At what height it is placed? This is AB. AB equal to 6 meter. Next, what you are going to find out? It is length of ladder. Length of ladder is AC, which is equal to question mark. After that, you can move on to the calculation. Got it? Dear students, now we'll go for copying from there to here. Copy this. Dear students, hope that you have copied up to here. So today, whatever the theorem we have learned, that is Pythagoras theorem, also called Baudhayan's theorem, and some of the statement which were proved. Please practice them today itself without fail. Okay. With this, let us stop the class. Thank you very much.